As we finish up Chapter 5, we're going to take a look at a grid dealing with the supply side of things. It's going to be our production cost revenue grid. As we look, it's kind of broken into three parts. We have our production point of view, number of workers working in a factory or providing a service, what kind of output are they going to get for that service. We look at a cost structure, looking at different costs incurred for that business, and then we have our revenue section, figuring out what kind of products are getting sold and at what prices. In turn, you compare your revenue section to your cost section. You decide whether you've made money or not. As we start out with the production side, you'll ask a question, ask students, who works in a business, maybe a Subway or a Dairy Queen or something like that, and say, all right, well, if you had 0 people showing up to work that day, how many ice cream cones get made? And logically, the answer would be 0. So in turn, if you have 0 workers, you get 0 product. Marginal product we'll talk about in a minute, but again, that would be 0. So then we'll ask that one student, say, all right, give me a ballpark guess. I mean, you would know better than we would. If you show up and work for 1 hour, and if this was a Dairy Queen, if you had to man the Dairy Queen by yourself and make things simple, all we're selling is ice cream cones. If you had to man the drive-through, make the ice cream cones, and man the front till, how many ice cream cones do you think you could get done in an hour? And we come up and say, well, for one worker, they can make, in this example, 40 product. When we start looking at marginal product is more. How much more are we getting? Well, if we compare from 0 workers to 1 workers, we got the difference between 40 product and 0 product. So our marginal product is 40. Okay, when you jump from 0 workers to 1 worker, you get an additional 40 units. In this case, we're talking about ice cream cones. So then we say, okay, if that works out, what if we go to 2 workers? Okay, so we go from one person made 40 ice cream cones. What if we add a second worker? What kind of bang for our buck are we going to get by adding that second worker? And maybe you have one worker who's going to deal with the drive-through and the till, and the second person's just going to crank out ice cream cones. And maybe when it's slow, they can kind of get each other caught up. But you look at it and say, all right, from 1 worker to 2 workers, our total product went up to 85. Okay, well, how much more are we getting? Marginal product meaning more. Well, 2 workers make 85, 1 worker makes 40. Marginal product is 45. How much more did we get by adding that next worker? Go from 2 to 3. You go all the way up to 130 units. Again, you do simple math and say, well, how much more are we getting for that? And the answer for this particular one is you get 55 more ice cream cones. Maybe now we have 1 drive-through worker who works the front till and the drive-through, and 2 people making ice cream cones. Okay, you're more and more efficient. Looking at the idea of economies of scale. And then we get up to adding our 4th worker. If we add up our 4th worker, we go from 130 to 180. Okay, now the difference between those two is 50. Are we getting more product by adding that 4th worker? Yes, we do. We're not quite as efficient though. Our most efficient point from what we can see so far is over here at 3 workers. Okay, we're getting the most bang for our buck. By adding that 3rd worker, we got 55 additional ice cream cones. Add that 4th worker, it's still more, but in this case it's only 50. You add that 5th worker, and now we start talking about, well, is there enough room in the Dairy Queen? Do we have people standing around? Do we have people making mistakes? Things like that. How much more when we add that 6th worker? How much more we get adding that 7th worker, and so on and so forth. As we notice, at some point in time, we become a little bit less efficient. Now, again, imagine in a small space like Dairy Queen, 8 people trying to do ice cream cones. That can be kind of a zoo. You may actually have diminishing returns. You may actually go backwards. You have people who are making mistakes, people who are not necessarily focusing on their job, people standing around doing whatever, and you may end up losing productivity. Another way to look at that in a kind of a visual standpoint is if this is a curve saying each new worker we add, we're becoming more and more productive. You notice how the curve is getting steeper and steeper. At some point, we are still getting more, but we're not getting as much as we used to. So that curve is kind of shallowing out. And then again, at some point in time, we're regressing or having diminishing returns. When we look at this, we'll call this stage 1, stage 2, and stage 3 of production. In stage 1, each new worker you get is going to get you more product, and the marginal product is going to continue to grow. In stage 2, you're still getting more total product, but as far as a marginal product goes, it's not as efficient. You're still getting more, but just not as much more. And then at stage 3, we're starting to go backwards. If we move from our production side of the grid, so we would get a grid here and we would fill all this out. Now there's some asterisks that you would put in with this. It is in theory. The theory being that each worker is equally trained, ready to go, and is able to get you more product to a certain point until you get into your diminishing returns. That obviously is not the case. Every worker is not made equally. In turn, when we start looking at our costs, not every worker is going to get paid the same. To make things simple, every worker is exactly the same. Every worker gets paid exactly the same, and it's simple. That isn't reality, but it's a simple way to start and kind of look at how this works. So we talk about our costs. We have two sets of costs. One's a fixed cost, one's a variable cost. When we look at our fixed costs, okay, costs that are always going to be there, okay, and they're not going to change with the amount of product being produced. Those are fixed costs. Now you think of some examples of things that are always going to cost the same regardless of how much product you're putting out or how many people you have showing up. If you think of Broadway hair, they flip on the lights when they come in. Now, whether there is just lined up out the door customers left and right, or whether there's nobody showing up, they still got to pay the light bill. Okay, they don't sit there and turn the lights on and then turn them off, and then when people show up, turn them back on again. They flip the lights on, they leave them on. That would be a fixed cost. That cost is always going to be there. It's not necessarily going to change. If you look at salary, salary meaning an employee that you're paid to do a job, and whether you get it done in 40 hours, 50 hours, 60 hours, doesn't really matter. A salaried employee would be a fixed cost. If you look at some of our variable costs, these are things that would change depending on the amount of a product or service being provided. You look at your hourly employee. Your hourly employee making $10 an hour. If they work 2 hours, they earn a certain amount of money. If they work 10 hours, logically they would get more money. Okay, so that's a variable cost. If you look at raw material going into a product, if you're making a particular product, the more product you're looking at making, the more variable costs you have. To make those work out, you take your fixed cost and you add it to your variable cost, and that's how we come up with total cost. In the examples here on our grid, we're going to make just simple examples. Obviously, it is more complex than this, but as far as our fixed costs, we're just going to call that lights. Okay? The lights are going to be turned on. The bill isn't going to change. We look at our variable costs, and we're going to call that our hourly workers. Okay? They're going to get paid a certain amount of money. Each new worker you hire, you're going to need to pay that worker the same amount of money. That may not happen in the real world, but for our example, each new worker is going to get paid $75 a day for working. You have 2 workers, now that cost goes up to $150. At a third worker, that cost goes up to $225, so on and so forth. Our fixed costs are going to stay the same. If we take our total cost That is just simply take the fixed cost, add it to the variable cost, and you'll get your total cost. We'll deal with marginal cost at the very end. Fixed plus variable equals total cost. If we jump out and we start talking about our revenue side of things, we've talked about the production side, we've talked about the cost side, other than marginal cost. We'll now get into the revenue side. When we look at marginal revenue, it's another way of saying selling price. Now, there's some underlying assumptions in there that every product that you're going to make, you're going to be able to sell. Well, we know that's not always true because you have products sitting on shelves, you have, clearance sales, things like that. The producer doesn't necessarily make the product with the intention of it sitting on a shelf and not being sold. They assume they're going to sell it. So when we look at our grid is assuming that whatever product we're making, we're going to sell every single one of them, and we're going to sell them all at $22 each. We know that doesn't happen. Maybe you buy in bulk and get a better price than $22 each. Maybe it's a clearance thing. Maybe it's a whatever it is. Maybe this price doesn't actually, pan out. Not every business sells the same product for the same price. Again, we're making things overly simple. We're going to make the assumption that whatever this unit is, whatever this product is, we're selling it at $22 a piece. Selling price. So how do we get total revenue? The important part of total revenue is taking your marginal revenue, or what your selling price is, and multiplying it by total product. We're assuming that everything we're making, we're going to sell. We have 0 workers, means we have 0 product to sell. 0 product times 22, 0. Okay, we didn't make any money there. If we have 1 worker, that's going to get us 8 total product made. Multiply that by 22, and we get $176 in revenue, money coming in. Get to our second worker. On our second worker, clean up that mistake there. On our second worker, we go from 8 units to 20 units, okay? We're selling each one of these units at $22 a piece. We have a total of 20 units that are getting made. That's how we're getting $400 in revenue. And you would just kind of work down the grid, taking your marginal revenue, multiplying it by your total product. Again, the assumption is you're going to plan on selling everything that you make, although we know it's not necessarily true. To finish up our production side of things, we look at our calculation of profit. And it's not all that different from Chapter 3 when we talked about the income statement. We talked about revenue, less cost of goods sold, less expenses, equals profit. We're taking kind of the same idea. We're taking our revenue, we're comparing it to our fixed and variable costs, and if we've made money, we've made profit. Okay, simple math, total revenue minus total costs equals profit. We head back to our grid, and as we clean up a little bit here, we're looking at employee 0. We still got $100 in total cost. We still owe money for the lights no matter how many people we have working, no matter how many customers we end up having. Okay? If we got $0 in revenue coming in because we made 0 product, yet we still had to pay the light bill, we ended up losing $100 there. If we get to 1 worker, we pull in $176. Again, we assume we're going to go ahead and sell everything we make. Our cost was $175. We made money. Not much, we made money. We broke even at $1. Second worker, we make $440 in revenue as compared to $250 in cost. We made $190 in profit. Last one here, third worker, $792. Cost $325 to run our company at that point in time. That's how we come up with profit of $476.